The final characteristic of a wave that I want to address is the speed of a wave. So characteristics of a wave, still continued from the last. And let's see, what number did we get up to? That was period and frequency were 5 and 6. So number 7 is going to be speed of a wave. In other words, how fast is that energy being transferred? Okay, so how fast is the energy being transferred? Okay, and different kind of waves propagate at different speeds. For example, you might have heard when you were a kid, oh, if you watch like a strike of lightning, you'll see it and then you'll hear the thunder a certain amount of time after, and that's associated with how far away the storm is. There is some truth to that statement because light waves actually travel significantly faster than sound waves. And the distance from the source is going to affect the amount of time it takes to observe those sound waves. So light waves travel significantly faster than sound waves, and thus you will see lightning before you hear thunder. Now, if you look in your reference table, you'll notice that the speed of light, which is represented as variable c, is equal to 3 times 10 to the 8 meters per second. However, the speed of sound is 3 times 10 to the 2 meters per second. Now, the reference table does give a specific value for this, but I just want to show it to you in terms of orders of magnitude right now, so you can see what a substantial difference it is. And there are two ways, by the way, we're going to come back to the differences between light waves and sound waves. But just as a side note, light waves are electromagnetic waves, and they do not require a medium to be transmitted. So light can travel through a vacuum. On the other hand, sound waves are an example of longitudinal waves, and I'll define that later on. And these do require a medium to be transferred. And not only do they require a medium, but sound waves actually travel faster in denser materials and the temperature will also affect that because these sound waves actually rely on air molecule collisions. Okay, but let's go back to speed of a wave. There are two different ways that you can calculate speed of a wave. So 2 ways to calculate. The first way you actually learned a long time ago. V is equal to d over t. Okay, so this is going to bring us back to our first unit, kinematics. The second method for calculating speed of a wave is v is equal to f lambda, where v is the speed of the wave, f is the frequency of the wave, and lambda is the wavelength. Well, what are the units for those two things? Well, frequency we know is measured in hertz, but we just said that hertz is the inverse of seconds. So let's just call it what it is, 1 over seconds. And frequency is being multiplied times wavelength, which is measured in meters. Well, here you go, meters per second. Okay, so we can calculate the speed of a wave in either of these ways, depending on what kind of information that we have.